Welcome to Full Throttle RC. I'm your host, Tony Castronovo. This show is presented by Warehouse Hobbies. Today we're going to talk about radio systems and the importance on installing them properly, reading the directions, understand how the radio system that you choose for your model boat works. So stay tuned, we'll get right to it. Okay, welcome back. Let's talk about the radio system. Today when you purchase a radio system, here's the basic components that come with it. You'll get a battery pack, a receiver unit, switch, and 2 servos. You'll also get a handheld transmitter. This is the device that controls both the steering and also the throttle with a trigger. Okay, when you buy the system, generally they'll come with 2 standard servos, and the standard servo is this particular servo. And you can see the size when compared to the next one, which we call or refer to commonly in the hobby industry as a quarter scale servo. And you can see the difference between the two of them plainly. There's almost 40% size difference. Now the reason we call this a quarter scale servo, and the name was deemed to it, was because it was commonly used in quarter scale large aircraft. And that's quarter scale from an original aircraft. And the control surfaces on a plane that big are large. And those control surfaces are subject to a lot of pressure by the wind. So we needed larger servos to be able to operate them. We find in model boating, it's a very intelligent thing to use these for the rudders too. Okay, in today's age, a lot of servo manufacturers are now manufacturing small servos, such as the standard one I have in my hand, but geared and more powerful motor inside to almost, if not equally, the amount of force that this larger one could put out. Okay, still in model boating, let me tell you why we choose to go with the larger ones over the smaller ones. Let's talk about racing first. In race format, generally weight is an issue, and a smaller servo and a more high-powered one for the rudder is generally applicable. But for us guys that we call the sport performance guys, the guys out there every weekend, I recommend, and we still use the quarter scale large servo. And here's the reason. A standard servo, obviously this big in size, would have relatively small gears inside of it to make it operate. Okay? In a larger servo, obviously we have a larger motor in here, but we also have larger gears. So the pitch of the gears are also much larger here. Pitch meaning the width between the gears. Whereas on the smaller one, they would be a lot thinner, closer together. Therefore, this particular servo, the quarter scale servo, can not only exert more pressure both ways, it can also take more of pressure. And here's what I mean by that. This particular servo, and we're going to jump ahead a little bit, we'll get into this a little bit more in depth in the show, this particular servo is going to be the one responsible for driving direct connection to the rudder. Well, that takes a lot of pressure in its own right with the water and obviously the speed of today's boat. But in the event a boat rolls over, barrel rolls or flips, as that boat re-enters the water, it can take that rudder and give it a good sharp jerk quickly like this. Well, that force is going to be transferred directly into the servo immediately. Now, the larger pitched teeth servos and the larger gears can withstand a greater shock or impact into this arm and move the gear train more so than the smaller one or even the smaller high-powered ones. So think about it. It's basically common sense. If you were to shear force that rudder, the larger gears with the larger pitched teeth stand a better chance to suppress the force without stripping or breaking the teeth than the smaller ones. And that goes for the smaller ones that exert more power. That is why I still recommend today the quarter scale servo used for the rudder. All right, let's talk about the receiver. Let's move some stuff out of the way here. The receiver is this little device, okay, with this wire attached to it, and the wire is the antenna. This is the receiving antenna. This is the device that's responsible for receiving the transmission from the transmitter, and it will determine what servo that functions and what that servo does. Okay, let's talk a little bit of importance. We're using a very standard system right now, which is your 75 megahertz standard frequency receivers. Today I'm aware that the new 2.4 gig and microwave radios are out there, but this is still the radio by choice to the masses, so we're going to pretty much concentrate on this. Okay, these wires, this antenna wire, this thin gauge wire, this is calibrated by the factory, determined by the frequency that this receiver responds to. So it is very important, guys, and I mean very important, that this wire is not deviated. In other words, you don't cut this, you don't wrap it up tightly and what you're not using. It is very important that this wire is used properly, and we'll explain that first before we go into any more detail. Okay. There's no better way to get reception from this receiver than this antenna to be as fully extended as possible. Now, granted, I understand we don't want a 20-inch antenna whip hanging out of the boat, and obviously we don't want it winding up in the propeller when we're running or the hardware. So generally the best way to do this, let me reach over here, is this, and this has been done for as many years as I can remember being in this industry. This is a tube type antenna, and basically what it is, it's a hollow tube. Okay, this is the one we manufacture. Okay, so it's all adjustable and you can remove the tube. This particular mount would mount on the transom of the boat. Okay, and it's very simple to operate. You'd remove the tube. The radio receiver would already be in the box. The wire would come out, would be routed out the box through a waterproof connector, and then drill a small hole through the transom and out, like so. Then what we'll do is we would put the wire up into the base, which is mounted on the back of the boat. Again, I want to show this without the boat this time, or radio boxes, because it makes it very difficult to see all the components if I have the display I usually use hooked up. So pretty much we can use our imaginations that this unit is now mounted on the back of the transom. And you'll notice that the receiver might be in this particular location right here, and the wire is nice and straight coming out the boat. We don't have loops and stuff like that. Now we're going to take the other end of this receiver wire, and sometimes it's a little tricky, especially on a new system. I'm using a used one here, so it's a little more difficult. We're going to route that through the tube, and the tubes, what I like to tell guys, and I've been for many years, generally the tube length should be no less than 8 inches, and usually a foot is really good. And I try to stay, I think we produce our tubes at about 11 or 12 inches. You're going to slide the wire up through the tube like this, and this one's not giving me any problems, so that's a nice thing, and until you see it come to the top. Then there's a black cap that comes with it, and you take about a ½ inch of that wire and you fold it down like this and shove the black cap over it. And what that's going to do is that's going to protect that wire and also keep it from sliding down the tube. So now it's fixed. It's a strain relief at this point. Then the tube would then slide into the base of the antenna, and ours really neat antennas. We have I still think we're the only ones in the industry with this. They've seen the copy of the antenna pretty good over the years. But we have a strain relief on the bottom that works with compression. So as the tube goes down the mount, as you tighten this little thumb screw here, it tightens the tube. And it makes it really neat, so when you want to remove the tube at the end of the day, you just loosen this up, you pull it out, and you can let it hang over in the boat, and you don't have this tube in the way to get bent. So that's basically how you want to set your antennas up. Okay, take a good look at this, guys. Next, let's talk about the battery box and the switch. Now, when you purchase your radios, you're going to find your systems. You're going to find that you get a standard 4-pack AA battery holder, which mounts 4 AA-sized batteries. Absolutely use alkaline batteries. This system is designed to run on 6 volts, and when you buy alkaline batteries, you'll get 1.5 each, so times 4, that's 6 volts. What I do want you to understand is this works fine, the 6-volt system with regular batteries, okay? We have added to this system the large quarter-scale servo. Now, obviously, the large servo is going to demand more of a current draw than the smaller servo. Okay, so I want you guys to understand, yes, you can get away with this. There's no problems with it. Just monitor your battery time. Very important. I tell guys that if you're using, Energizers or Duracells, whatever alkaline batteries you use, that you run these, you have about 4 consistent hours on this pack, and then get rid of the batteries, okay? What are your batteries are $5 today, $4? It's not worth your $1,000 boat over a $4 or $5 set of batteries, okay? So that's really important. So if you choose to stay with the standard AA pack, which again is fine, just monitor your time. Because the next choice you have is to go to a larger pack. And today we have the lithium polymers and generally speaking, larger nickel metal hydride packs. And let's talk about that for a while. I don't have one in front of me here, but basically, you all realize that the larger the battery, when we're talking about nickel metals, for instance, or we're talking about alkalines, the larger the physical battery size, the more current capability that battery generally can put out. Okay, so it all applies here. So if you're going to go out and you've got a large boat and you're going to spend all day running that boat, it does make sense to invest in like a 5 sub-C cell battery pack, nickel metal hydride, and you can get something, anything today it's very tough to find anything less than 2,000 milliamps. And keep this in mind, the more amperage is not going to have any effect on if it can do any damage to your radio. That's absolutely contrary. It's not. The more current capability a battery can discharge, the longer your radio will work. So if you had a 1,200 milliamp battery capacity, and let's say that it would last, let's say 4 hours, just depending on the usage, that if you were to go to a 2,000 or a 2,400 or even a 3,000, that would, in essence, double the ability for that battery to deliver power to the servos. And it's your servos that are going to pull the current. So the larger the boat, multiple rudders, large servos, all this contributes to how long the battery life is going to be. And also the smaller capacity batteries, such as an alkaline here, which I think, if I'm not mistaken, I think they're 500 milliamps, a half amp capability. Okay, so even in series like this particular pack, that's a half of an amp. Okay, versus your large sub-Cs where you can easily get, obviously 1.2 amps is 1,200 milliamps, 2,000 milliamps is 2 amps, and on. So you can see that the larger batteries do benefit in the long run, both on how long they last and also, more important, power. The more an electric motor doesn't know any better on what it's doing for exertion. An electric motor, when put under load, will draw the current that it's able to get. So if this battery pack can put out at best half of an amp, and you put this particular servo under an excessive load, that's all you're getting. And remember something, current is power. Okay? If in this case, let's say you had a 3,000 or a 3 amp capability, and this motor inside here needed it, it could take it. And the more current, the faster response, and the more you're going to get out of your servo. But again, there's nothing wrong with running 4 cells, providing that you monitor the battery time. All right, let's get the system connected, but first we're going to talk about the switch a little bit. Your radio system that you purchase is going to provide a switch, which is going to turn the system that's in the boat, these components, on and off. Okay, I did something a little unorthodox here. I used parts, and rather than take a new system out of the box, what I'm going to show you guys is you can interchange certain manufacturers' parts, and that's what we're going to do here. Here we have a Fatava receiver. We have a high-tech battery pack. I believe we also have a Fatava switch, okay? And what I want you to notice is these connectors, okay? Because some of the connectors they're polarized. And what that means is, obviously, it's to get the polarity right. Remember, this is DC. Red goes to red, black goes to black. Red is your positive, black is your negative. Some manufacturers design it so there's no potential in plugging the system in wrong. And you can see when I plug this switch in, for instance, to itself, just to show you, that I can't plug it in this direction because the plastic is designed to fit in this receiver only one way, and that's called polarized. So if I turn it around, it allows the fit and it plugs in. This all but guarantees you're not going to get a reverse polarity. Okay, but we're all big boys here, so we don't have to worry so much about polarization. We just know red goes to red, black goes to black. Let's take this high-tech battery pack, which is a 2-prong, and your input to your switch, which is unique to the connector for that system, okay? Well, we're looking at these two, and the problem with this, the only problem with this is you could plug this switch in inevitably any way. So all we have to remember is black to black, red to red. So let's polarize this right by eye and plug it in. And you can see that it works just fine. Okay. Let's talk about hooking the system up now. Proper connections. Let's make sure either you have the batteries out of the receiver to do this or the switch is in the off position. Okay? Both are good. We have the switch in the off position. This particular radio, again, this is a compatible connector to this receiver. So it's not going to allow me to plug it in backwards. But just remember this. Here's another rule of thumb. Generally on all manufacturers, when you plug in the plugs to the receiver, the black lead is always to the outside of the case of the receiver. So that would mean anything you plugged into these, the negative would be to the outside of the case, positive to the inside of the case. So that's something good to remember, and I bet you a lot of guys didn't know that. So let's plug the battery in first, and that's what we're doing here. And you can see we plug that in, and negative's on the outside, facing the outside of the case. Okay, now let's take channel 1. Channel 1 is your steering channel. And again, this particular connector is not a polarized connector for this receiver. So we're going to look at the black wire being on this particular side, the right side, which is also going to face the outside of the case. And we're going to plug that in like that. Okay? And you're going to see the black on the outside. The red would be generally in the middle or facing this side, the opposite side of the case. Then let's take the throttle servo. And this is a polarized one. This is designed for this receiver. So it will only let me plug it in the proper way. And that is channel 2. So to summarize all this, we're going to plug in the battery to where it says battery on the receiver with the negative to the outside of the case, positive to the inside. We're going to plug in channel 1 steering with the negative to the outside of the case with the positive inside. And obviously the one that's designed for this system, the Futaba, is going to only allow us to plug it in where the negatives to the right of the case and the positives to the inside. You'll also see that you have a tracer wire. This is very important on your servos and not so on your switch or battery harness. And let me explain what this is for. This white wire, or yellow wire in this case, this is the wire that's going to take the signal from, it's going to take the receiver is going to get the signal from the transmitter, and the transmitter is going to decipher this signal. And it's going to tell what servo to operate, and that particular wire is going to receive the trace signal to that servo, telling it what to do. And that's basically why servos have 3 wires. So they have to have 3 wires. 2 are going to be your power. One's going to be a positive, one's going to be a negative. The third is going to be the tracer or your signal wire. That's going to be the carrier that's going to tell the servo what to do. And that's how the system should be connected, that is inside the radio box of your model boat. All right, one of the most important things that I did leave out, because I started the show abruptly and I should have brought this up, and a lot of guys don't do this. You know, we manufacture quite a few boats a year, several hundred to be honest with you, and most of them, or the majority, people want us to put radio systems in. We include the manufacturer's directions for every radio system and servo that we use. And because we have set it up in the factory, a lot of guys tend to take the boat, you know, it's already been set up, and go right out to the lake with it. They've never done this before, and that is absolute no-no, guys. It is so important to read and understand how these radios work. And today, every year they're adding new features to them. And I like the workhorse of the industry. We use the Futaba Magnum Junior. We've used this radio since its invent back in the mid-'80s. And it's changed over the years. It used to be all analog with knobs. Today it's pretty much computer-driven. But it's still its simple form of radio. It doesn't have all the bells and whistles that we don't need as model boaters. The last thing we need is all types of computer-aided products. We don't need that. We have 2 channels. We need to go right and left, fast and slow. We need to be able to reverse the servos. We need to be able to set the limits of the servos and dual rates. And that's even, you know, iffy. I mean, dual rates are nice. It allows you to adjust how far you want the sweep to go. You know, something your brain used to do years ago, but now we're getting kind of lazy. But it's a nice function. And that's basically about it for what we expect out of our radio systems. Okay. So the first thing we do before we even get to the point where I've got to today is if you receive a boat from us or you purchase a radio and you're going to install it yourself, go through the manufacturer's directions, understand how every function works. It's something I didn't know. I mean, I got a lot to do around here. I didn't know that these radios now can handle 7 model memory. My kids brought that up recently. You know, they're out practicing all the time now that they work here. And in other words, this radio can be programmed to I think they said 7 or 10, maybe 10 different frequencies in the transmitter and set up for 10 different boats with one radio. That's pretty cool. You know, I knew it existed, but I didn't know it did on this basic radio. This is a basic, I guess, what, $100 retail radio with less to servo. So that's a neat feature. Again, Read so you'll learn all this and how it works. Don't take for granted that we set up your boat and you go out there and play. You have to understand that if you bump a knob or press the wrong button and you throw something out of sequence, we might have the servo limits at 60%. You can actually accidentally push a button and limit it to 20% and go to make a right turn, and it takes a half of a football field to do that. Again, you have to know how to go into the parameters of the radio and make these adjustments. So the directions will explain that. I'm going to teach you on the hardware and the fundamentals of setting a system up properly. And you really need to refer to the radio manufacturer's instructions to really understand how it works. Well, enough of that, though. Okay, let's talk about starting the system up. A lot of guys don't know this, and I want to go through this so we all understand it. First thing we're going to always do, is we're going to put the antenna up, okay, because we don't want to be sending the signal to nowhere or overpowered, and we want to turn the transmitter on. Remember this, guys. Always transmitter on first, okay? The reason being is when you reach over to turn on the receiver, okay, it doesn't pick up a stray signal somewhere or glitch a servo and your boat takes off across the shore and by the pond, and by the time you get to your radio, it's too late. It's already hit the neighbor's boat or a dock, okay? So transmitter on first, followed by the receiver. Okay, once that's on, the system should operate. And you'll see as I turn the steering wheel right to left, the servo moves one way right, and the other way left. And the same with the throttle. As I squeeze the trigger, the servo is going to move one way. As I release it, it's going to move the other. Okay? And this is, again, I don't know if I have to say, this has been around for a long time. This is called digital proportional, meaning that it's proportional to, if I move this steering wheel 1/8 of an inch, the servo responds 1/8 of an inch. And I say that because I come from the days where that didn't happen. You know, if you moved the steering wheel a little bit, you didn't know where the servo was going to end up. You know, so it's great today. Radio systems for the last 20 years have been almost flawless. Most boat crashes that happen are, believe it or not, are driver or operator error today. Chances of a radio failure outside of getting the system wet is pretty slim. Okay, let's talk about this. Okay, we know now that this is how the system works. Let's do something. Let's pretend this is all in the boat right now. We'll get back to the hardware later on. Let's pretend this is all in the boat right now, and I'm ready to run my boat. And it's new, and I'm new at this. And even if I'm an old timer at this is something we should do all the time. And I know even us older guys get complacent to this because we put a lot of faith into our workmanship, into our radio systems. But I'll tell you something, guys. You heard this, and you watch every model airplane guy and a helicopter guy. I don't care if they've been doing this for 50 years. From the advent of the tube radio, it's called a range check. Okay. Now, you got to be a little careful when you're this close because it's not uncommon that on a standard radio system, being close to the receiver, both antennas could cause the servos to glitch a little bit. So usually 4 or 5 feet away will straighten that out. A lot of times I get calls and say, hey guys, Tony, I got my radio next to my boat and it's jumping around. That's possible, okay, to happen. So keep your radio away. Let's talk about how we do a range check. We've turned the system on. Okay, the boat's shut off. We're going to do it 2 ways. We're going to put the antenna down, and we're going to bring it down to maybe this one segment right here is fine, okay? And we're going to start walking away from the boat. And you really want to set, if you're by yourself, you want to set the boat up so you can, view the rudder. And as you're walking away, turn your steering wheel back and forth and watch your rudder movement. Generally, with the antenna down on the transmitter, the rule of thumb is 50 feet away. If you can get 50 feet away from your boat, and that rudder is doing what you want it to do when you tell it to, that's pretty good. Now, go back, start the boat, and do the same thing. Let's make sure that engine interference isn't a problem, okay, or a factor. And we'll talk about that in the next segment because we're going to do 2 segments on radios. There's so much to talk about. So we have the boat running, gasoline engine, and we're going back. We're going to do our 50 feet. Now we can throttle it and listen to the response of the engine. We'll know. You'll know if you have a glitch. If you start getting 10, 20 feet, 30 feet away from your radio system and it's not doing exactly what you want, it's time to stop at this point and find the problem. Okay, you do not take a chance and put the boat in the water. That's irresponsible and dangerous, okay? Not only to personal property, but to persons and yourself, okay? So you never run a radio model boat if you're not 100% satisfied with the range check you've done, okay? So now we're ready to go. And basically, we can go and play with our boat. And everything's great. Well, when we bring the boat back in, I want you to remember another thing, okay? Remember we talked about transmitter on first, followed by the receiver? Okay, we're going to do the same thing on the way back in, but opposite. We're going to turn the receiver off first, okay, then the transmitter. And why are we going to do that, guys? It's simple. If we were to turn the transmitter off first, and we have our boat sitting there running in the water, maybe next to the dock, because you made this cool entrance for people to see, you turn the transmitter off, and it picked up a straight signal, boom, it's gone. Hopefully, you know, it doesn't hurt anybody or destroy any property. But I've seen this happen. I've had it happen to me. Always leave the transmitter on first at the end. You turn the receiver first off, okay? Then followed by the transmitter after your engine's turned off. Always turn your engine off first before you do this, okay? We'll get into some details on how to set this system up in a second. Okay, here's a question that I answer all the time, okay? Guys will call me up and they'll ask, how do I set up my throttle? How do I set up my rudder? What's the best place to put the servo? Should they put them sideways? Should I put them this way? You know, when you buy our product, like our radio box and servo tray, it's pretty predominant. We cut the servo tray so the servos go one way. Now, we do that because we found the easiest way to mount the servos for our application. And again, it works pretty good for you guys building your own boats too. But let me tell you, this is very important, and this is the best way I can explain it. And I've been doing this for an awful long time. There is no right or wrong way to hook up your components in your model boat, your model car, your model helicopter, your model anything, airplane, okay? Providing you don't overwork the components. All right? That's as simple as it gets, okay? And there's a couple of things, you know, I see a lot of guys lay the certain side, and I've done this before, lay the servos on their side, okay? There's nothing wrong with that. They have mounts. Either they fabricate mounts or buy mounts. And this allows you to get a real low-profile radio boxes. In some cases, you need that. But if you have a large boat, like especially when enforcer boats come, you know, this becomes more of a pain in the butt. Why would you can't access anything. You can't adjust anything easily. If you had to take the horn off, you obviously can't get into the radio box to unscrew it. That means you got to unscrew the servo, take it off the mount. So if you have the room, why make it difficult for yourself? Mount them up and down. It's easy. Now you could, if you had to take a servo out, it's very simple. Standard screwdriver. If you had to take a control horn off, it's very simple to do. That's why you'll see all enforcer products like this. We try to. Unless we ever get ourselves in a situation till we don't have the room, you will see the servos standing straight up and down. Okay, what did I mean by overexert the servos? This is simple. If this servo, let me explain how it works, okay? Let's get this, let's turn it off so I can free move one. And if you have to move these arms, you're moving an entire gear train. I didn't touch on this, okay? Let's do it nice and gingerly. You don't want to be cranking on those because you can damage them, okay? If you really, especially the smaller ones, okay? Larger ones, like I said, they'll take more abuse. But basically, how the servo operates is it has a center point, okay? It has a center point, which we call neutral, or you can use the whole sweep, basically 180 degrees. Okay, let's turn it on so I can show you what I'm talking about. If I was to move this, like I am, wheel deflection to deflection point, I'm almost getting about 180 degrees. And that can be, again, that can be adjusted out with the transmitter. You can actually set that. If you don't need that, we'll talk about that part later, okay? But I just want to show you how they work right now, okay? So generally, the center point of that horn will make that the neutral point, for instance, or where the rudder is straight. Okay, I'm going to remove it so I can show you guys how simple this really is. Okay, we'll pop it off. It's on a spline, so you can put it anywhere. This thing, and the neat thing is the spline. The spline has it's a lot of fine thread spline, so this horn can be incrementally set anywhere. So let's set it to the center. Okay. We have the radios trimmed to the center. And it'll give you an idea how this works. Now, what I was talking about making everything work smooth is, as long as the servo rod, for instance, the rudder rod is coming off this servo, and it can move its travel freely and not bind, not hit anything, okay? It doesn't matter where or how this servo is located in the box. It could be up front. It could be in the back. It could be sideways, providing it moves freely. And a good indication of whether a servo moves freely is listen to it when it's running. You'll hear it. It's a fast sound. If you hear it groaning or humming, or it has a buzz when you turn it on, humming, that normally indicates that there's force put on the horn, and you can actually you know, I wish you guys could feel this, but next time when you do this, give it a little pressure on the servo. As soon as you push that arm where it doesn't want to be, you're going to feel a vibration. And I'll get into that on the next segment about what causes the vibration. It's the design of the servo, and I'll explain that to you. But if you put enough pressure on that horn to where you feel that vibration, you are forcing that servo to be in a position that it's not that the transmitter and the receiver are telling it not to be. And by doing so, you are now powering that servo up and drawing current. Okay, it's sitting there with some pressure against it, and it's actually working a little bit, and it's pulling current to do so. Plus, it's probably not healthy for the motor in it to be sitting there in a non-active state, being forced into an active state. Okay, so if this can move freely, it's fine. Same with the throttle. Doesn't matter where or how you put this servo. As long as when you pull the trigger, it freely pulls the throttle open and closes it. Now, a lot of guys in racing, they like to run, I use this because we're generally a little bit different. We like to run a cable throttle. We have been running cable throttle since the early 80s. Very successful at it. Love them. Easy to hook up, easy to maintain. Okay? You're not subject to putting the servo in one specific place. If you don't have room, you can move your servo wherever you bring the cable, sort of like a bicycle cable for a brake. Wherever you bring that cable, you can hook it up and it works fine. Providing your cable is manufactured properly, it's not excessively long, it doesn't have loop-de-doops in it and stuff like that, cable servos work, cable throttles work fantastic. I'm not an advocate for cables on the rudder system. I like hard wire on that and also large hard wire, like 440. You guys, not the 256, 440 on the large rudders. Okay? Pretty much that's how you hook up a radio. So if you put these servos anywhere you like, and you can hook them up any way you like, and it makes the function when right and left and gets you the right deflection that you need, and also the carburetor, the right deflection. You want to be able to open and close all the way. Very important to close, more so than the open all the way, guys. That carburetor closes. And again, all that can be controlled by the radio, which would dial in more or less servo. And when you read your operator's manual, it'll explain all that and how that works. So that's what I mean about there's no right or wrong way. So just because you might see an Enforcer radio box laid out that says, okay, the quarter scale servo's on this side here like this, and the steering servo's on this side here like this, doesn't mean that it can't be like this on your boat or like this on your boat, okay, your own project. Whatever way works the best, you have the room for, and does not strain the system, is okay with me. And also, I'm sure the radio manufacturers. Boy, I have a great time doing these shows, and Chris is whispering in my ear that it's time, you know, and I went a little long on this one. So what we're going to do is we're going to break up the radio show into two segments. We're going to do a segment B, which is going to go into depth about doing some servo repair, testing servos, bad crystals, and some great stuff. I appreciate you joining me today on Full Throttle. My name is Tony Castronovo. We'll see you next time.